Good morning. My name is K. Purushotham, working as Assistant Professor in the Department of Electronics and Communication Engineering from MLR Institute of Technology. So, previous class I discussed about what are the different types of FM modulators we are using. So, those are the two types of FM modulator. They are classified based on the value of beta. Beta less than 1 and beta greater than 1. Beta less than 1 means narrowband FM. Beta greater than 1 means wideband FM. So, narrowband FM we have generated, which is similar to the AM. And wideband FM also we have generated. Wideband FM again we are classifying into two types. Those are nothing but first one is direct method of the generating the wideband FM by using the voltage control oscillator. Second one is indirect method of generating the wideband FM. Other name for indirect method is nothing but Armstrong method. So by using the Armstrong method we are generating the wideband FM. So first we are generating the narrowband FM, then we are multiplying the frequency by using the frequency multiplier. Then we are getting the wideband FM where the beta value is greater than 1. So the today lecture we are concentrating on demodulators. What is the function of the demodulator? So by using the FM modulator we have modulated the signal and we have transmitted. So the S of T is nothing but modulated signal which contains the original information and the carrier signal. So but at the receiver we want to obtain only the original information. To get back original information, we are using the demodulators. Demodulator main function is nothing but it is demodulating the received signal and obtaining the original information at the end of the demodulator. So here what type of the demodulator? There are n type of demodulators we are using for the demodulating the FM signal. So I am concentrating on balanced FM slope detector or balanced frequency discrimination method to detect the original information from the received signal. So now here the black diagram of the FM slope detector or balanced frequency discriminator. The first input FM signal, modulated signal we are applying. FM input from IF amplifier. IF is nothing but intermediate frequency amplifier. This is the primary section and secondary section is the center tapped transformer. So the center tapped transformer output is connected to the diode and output of the diode is again connected to the load resistor R1 and C1 and center tap transformer bottom end is connected to the diode D2, R2, C2. This R1, C1, R2, C2 which are used to remove the ripple content or the AC component which is present inside that signal. So ripple, the variation can be removed. So now according to the first, the input transformer is a center tapped secondary and input voltage to the two slope detectors are 180 degree out of phase. The center tap transformer it is providing the phase shift upper to the bottom. Okay, there is a 180 degree phase shift is there from upper side to the bottom side. There are three tuned circuits are there. First one is primary tuned circuit which is tuned to the IF value and upper tuned circuit of the secondary T1 above FC by del F, that is nothing but FC plus del F, and lower tuned circuit that is del F, again it is tuned to the FC minus del F. So first primary is tuned to the FC carrier frequency and upper frequency value FC plus del F and lower frequency value FC minus del F. Okay. So the R1, C1 and R2, C2 are the filters used to bypass the RF ripple content. The ripple value whatever is present at the output of the transformer, the ripple content can be eliminated by using the filtering sections. Filter which is a frequency sensitive device. Depending on the configuration it will allow certain range of frequencies and it will not allow certain range of frequencies. So here the output is V01 and V02 are the output voltages of the two slope detectors. The two slope detectors, what is the output we are getting here? Here two slope detector. Upper slope detector which is tuned to the FC plus del F, lower tuned circuit FC minus del F. So V01 corresponding to the upper slope detector corresponding to the lower slope detector V02. So output voltage is nothing but V01 minus V02. V0 is nothing but the difference between these two. Y means the center tap transformer, the secondary, which is providing from the upper to the lower, it is 180 degree phase shift it is providing. So the V0 is nothing but V01 minus V02. So here, we know the equation of the FM wave. S of t AC cos 2 pi FCT 2 pi Kf integral M of t dt. So the differentiate the above equation with respect to the t. So this S of t expression we are differentiating. ds of t by dt is equal to AC 2 pi fc plus 2 pi Kf M of t sin 2 pi FCT plus 2 pi Kf integral M of t dt. Okay, we can write minus sin theta is a sin theta minus 180 degree. And we are substituting here M of t sin theta. This is the sin theta we have taken. That sin theta we are representing as a theta minus 180 degree. So theta is 2 pi FCT plus 2 pi Kf integral M of t dt minus 180 degrees. Okay. So in this above expression after differentiation, whatever the value we are getting, this is the value. This is nothing but envelope. Envelope of the slope detector. Envelope of the slope detector output. So here amplitude term resembles the envelope of the AM wave. Already we know. So where the original information is containing modulating signal amplitude. So the envelope of the signal is containing the original information. From this envelope, we have to extract the M of t. That is nothing but what we have transmitted from the transmitter section. Modulating signal, what we have transmitted from the transmitter section. Same modulating signal we have to obtain at the receiver section. Here our requirement is the modulating signal M of t. Hence, we can recover it from the envelope of the AM wave. We have to recover it from the envelope of the AM wave. So for that, one more circuit we are using, that is nothing but FM wave S of t is applied to the differentiator. Then differentiator output is connected to the envelope detector. So the envelope detector output is nothing but demodulated output, and that is nothing but M of t we are getting what we are transmitted from the transmitter section. So this block diagram consists of differentiator and the envelope detector. Okay, this means convert the frequency variation of the FM wave into the corresponding voltage or amplitude variation of the AM wave. Voltage variation, frequency variations are converted into the voltage variations. So that is nothing but amplitude wave. So we know the operation of the envelope detector. The envelope detector what we have discussed in the AM demodulation section. So there what it is doing, it is detecting the original information signal from the received signal. So there we have taken the time constant, tau is equal to RC, charging time constant and discharging time constant. Charging time constant is very low, discharging time constant is very high, and output signal what we are detecting is containing the similar to the AM signal. Okay, same we are following here. Working operation of the circuit. The circuit operation can be explained by dividing the into three sections. So there are three sections are there. So first section is tuned to the FC. Second section is tuned to the FC minus del F and FC. Within the F value is lying within the range of FC to FC minus del F. And another one is lying within the range of FC to FC plus del F. So initially it is tuning to the FC, carrier frequency. Once it is tuning to the carrier frequency from the primary to the secondary, so what is happening? Upper tuned circuit input D1 and D2 are equal. If the signal FC, if you are tuning, input signal is containing the FC, input signal is containing the FC plus del F, input signal is containing the FC minus del F. So FC plus del F, FC minus del F, that is nothing but high frequency and low frequency values of the modulated signal. and FC is nothing but the carrier frequency, center frequency. So if it is tuned to the FC, the value of upper diode what we are getting V01 is equal to the V02. The lower circuit value, upper circuit value both are same. And as per the central transformer principle, what is the output we are getting? V0 is equal to V01 minus V02 we are getting. Okay, so finally if it is tuning to the FC, V01 is equal to V02. So what is the value we are getting? V0 is equal to V01 minus V02. So if it is tuning to the FC, V0 is equal to 0. If it is tuning to the FC, V0 is equal to 0. Next, if it is tuning to the FC plus del F to FC. So upper tuned circuit. If it is tuning to the upper higher value, so what is the value we are getting? Input D1 is higher. So for that V01 is greater than V02. V01 is greater than V02. So V0 is nothing but what is the value we are getting? V01 only we are getting. V0 is V01. That is nothing but positive value. Positive value we are getting. Okay, this is nothing but positive value. This is nothing but positive value. So if it is tuning to the lower circuit, that is nothing but less than, if it is tuning to the lower frequency value, that is nothing but FC to FC minus del F. So here D2 is more than the D1. D2 is more forward bias than D1. That is nothing but V02 greater than V01. V02 is greater than V01. So what is the V0 value we are getting? V0 value we are getting negative. V0 value is negative. So here V0 value is negative. Here V0 value is positive. So what is this range we are calling? This is the useful range or linear range. Useful range or linear range. So this linear range we are using for the detection of the original signal, original modulating signal we are extracting from this linear range. Okay, beyond this we are calling it as a non-linear range. We are not concentrating to extract the information from this non-linear range. So this linear slope detector, the slope is varying linearly from FC minus del F to the FC plus del F. So this is the useful range we are using to demodulate to the original information signal from the received signal. Okay, so that's why we are given this is the slope detector. If the output frequency goes outside of the range FC minus del F to FC plus del F, the output voltage will fall due to the reduction in the tuned circuit response. Reduction in the tuned circuit response. So we are not recommending this beyond the non-linear range. Beyond the linear range we are not recommending. That is nothing but non-linear range we are not recommending for extraction of the original information signal from the received signal. So what are the drawbacks of the slope detector? It is inefficient. It is not suitable and it is linear only over the limited frequency range. That is nothing but FC minus del F and FC plus del F. Only within this range only it is existing. Beyond this range we cannot recommend for the demodulation of the signal. So this is the restriction. It is difficult to adjust the primary and secondary winding of the transformer must be tuned to slightly different frequencies. So the exact FC minus del F, FC plus del F, it is very difficult to tune the secondary of the transformer according to the modulated signal what we are getting across the primary input. So tuning is also difficult. So and the advantage of the slope detector is nothing but it is simple. The simplicity, easily we can design the slope detector. So this is the advantage and remaining are disadvantage. We are switching over to the Foster-Seeley discrimination method of demodulating the FM signal. So different and ratio detector is also we are using for demodulating the FM signal. So according to our syllabus, we are concentrating only one slope detector. So other slope detectors also faithfully they are working and they are extracting the original information signal from the received signal. Okay, so this is about the FM demodulator. So the today class what we are discussed. So what is the FM function of the FM demodulation? Demodulation is nothing but extracting the original information signal what we are transmitted from the transmitter section. For that we are using slope detector. The slope detector is containing the primary winding and secondary center tap transformer. So the secondary center tap transformer is providing the 180-degree phase shift from the upper to the lower, and upper is tuned to the FC plus del F, lower is tuned to the FC minus del F, and we are classifying into three regions. EPT tuning to the FC, and EPT tuning to the FC minus del F, and EPT tuning to the FC plus del F. So in this among three regions, we are concentrating in the linear region for extracting the original information from the received signal. Okay, this is about the FM slope detector. Thank you.